Hello everyone, I am PR Manoj Kumar. I am studying mechanical engineering at Madras Institute of Technology. Today we are going to see about blast furnace. Now let's see the components of the blast furnace. Let me point the component of the blast furnace. Uh, this is the raw material storage. From here, the raw materials are collected through the skip car and it is transported to the top of the blast furnace. And this is the main furnace. And these are the two hot blast stoves. And uh, through here, the slag is collected through the vehicle, and through here, the molten metal is collected through the vehicle. Now, let's see the overview of blast furnace. A blast furnace is a type of metallurgical furnace used for smelting to produce industrial metals, generally pig iron, but also others such as lead or copper. Blast refers to the combustion air being forced or supplied above the atmospheric pressure. A blast furnace is a steel cylinder lined with refractory. A vertical shaft furnace that produces liquid metals by the reaction of a flow of air introduced under pressure into the bottom of the furnace with a mixture of metallic ore, coke, and flux fed into the top. Evolution of blast furnace. Due to the increased demand of iron for casting cannons, the blast furnace came into widespread use in France in the mid of 15th century. The ancestor of those used in France and England was in Namur region, which is modern-day Belgium. The size of the evolution of blast furnace based on the size is shown in the picture. Here they are classified based on the earth diameter, total height, and the productivity. The raw materials used in the blast furnace, the calcium ore, coke, and limestone are added as raw materials. Here, the ores are hematite, Fe2O3, sinter, and magnetite ores. Coke acts as the fuel, and limestone acts as the flux. In addition, the iron fines are added. Natural or direct shipping iron ores contain between 50 to 70% iron and can be fed directly into the blast furnace. Coke is a reductant or a chemical that reduces iron oxide to iron metal, especially when combined with heat and oxygen. Skip cars. Iron oxides, flux agents, and metallurgical coke are added to a skip car at the stockhouse. The skip car ascends through a skip bridge to the top of the blast furnace where it is emptied. The skip car is a small cart used to carry iron ore, coke, limestone, and furnace. It travels through the furnaces on a skip hoist. A skip hoist consists of a bucket mounted on four rollers traveling on a T-rail or angle track structural runway. Hot blast stoves. A stove is a heat exchange vessel. Stoves absorb heat from the combustion of blast furnace gases with air and transfer this heat to the air blast that will be injected into the blast furnace to a hot blast stove is used to blow the preheating air into the blast furnace. This is an important step in the raising of efficiency of iron processing. The stove is a vertical cylinder steel shell lined with fire brick and with the interior separated into two chambers, combustion chamber and the regenerative chamber. Pulverized coal injection method. Pulverized coal injection (PCI) is a process which involves injecting large volumes of fine coal particles into the raceway of the blast furnace. Pulverized coal injection is a process which involves injecting large volumes of fine coal particles into the raceway of the blast furnace. In this picture, we can see the pulverized coal injection mechanism. The PCI method is based on the simple concept of primary air, which is the conveying gas carrying pulverized coal, which injected through a lance to the tuer at the mid-bottom inlet of the blast furnace, then mixed with secondary hot air which is the blast, supplied through a blowpipe in the drawer and then piped to a furnace to create a balloon-like cavity called a raceway, which then propagates coal and coke combustion and melts the solid iron ore, releasing molten iron. The most remarkable aspect of this method is that it allows for cheaper coal to be consumed in the system, replacing expensive coke, thereby remarkably cutting down on costs. Because of the severe environment inside the furnace, which is greater than 2000 Kelvin, visual observation of raceway shape and size is impossible. Therefore, remotely measuring sensors are used to investigate the chemical and physical reactions inside the furnace. Now, let's see the process which takes place inside the blast furnace. Let me show this using a pointer. At first, the iron ore, coke, and limestone are charged at the top of the blast furnace. The arc-based gases are go- goes out through this outlet. At 700 degrees Celsius, the reduction of iron ore takes place. At 850 degrees Celsius, limestone decomposes and slag forms. Carbon dioxide reacts with coke. At 1500 degrees Celsius, hot air reacts with coke, which at results form molten iron. Molten iron leaves the blast furnace through this outlet, and the molten slag leaves the blast furnace through this outlet. The end product of the blast furnace. The end products are usually molten metal, slag tapped from the bottom, and the phase gases, which is the flue gas, exiting from the top of the furnace. The liquid hot metal and slag are tapped from the blast furnace intermittently or continuously depending on the size of the furnace. Hot metal is tapped into a torpedo car, which is transported by rail to the hot metal pretreatment station, and the blast furnace slag is tapped into a uh, slag ladle, which is transported by trucks to slag pit. At the slag pit, slag is water cooled, processed, and sold as aggregate material. Cooling system in a blast furnace. Function of BF cooling system is to cool the furnace shell and prevent from the overheating and subsequent burn through. Cooling system removes the excess heat generated in the blast furnace, which is otherwise loaded on the shell. Cooling system hence prevent the increase of the shell and lining temperature. A stave is a cooling device having one or more internal water channel and is installed in numbers on the inner surface of the blast furnace to protect its steel shell and the high temperature gas and molten burden material in the furnace and maintaining the profile inside the furnace. These are the types of cooling arrangements in blast furnace. Cast iron stave cooling, mass cooling by radial spaced copper plate cooler, cast iron stave with brick support, ma- mantle stave cooling. By this, we can conclude that uh, blast furnace is one of the vital unit in a steel manufacturing plant. Thank you.